For each real number r, which of the following points lies on the graph of each equation in the xy plane for the given system? So I rewrote the equation here that you can see better. Now think about these two equations that they are identical. And how do I know? Just multiply the top equation by 4. Well, you're going to multiply 4 on both sides, but you can also multiply everything by 4. And you're going to get 28x plus 24y is equal to 20, which is the same thing as the bottom equation. So this means that for given x and y, they should be equal under all cases of r. Okay, so the goal is to choose a coordinate that will satisfy that whatever you put for r will give you the both sides of the equation equal. So the only way we can double check this is through each choice. Hopefully the answer is A, but if A doesn't work, then we gotta try B and C and possibly D. So let's start with the choice A. So you guys know that this is given coordinate, x equals r, y is equal to that expression in terms of r. So let's plug it into top equation. However, I just also realized that this equation can be further simplified. Notice that we have a GCF of 28, 24, and 20 will be 4. So when you divide it by 4, that will give you 7x plus 6y is equal to 5. So using that equation, let's plug it in. That's x equals r. And the y equals negative 6r over 7 plus 5 over 7 is equal to 5. Okay, so when you multiply this, okay, now I'm not gonna go further, and do you know why? If these two system of equations are same, we really expect these r expression to cancel out, and then we should expect the numbers on the left side and right side after simplification should equal. And the moment I get something like 7r minus 36r over 7, I don't have to go further. I mean, you get r equals something. We don't want that because we want infinitely many solutions based on the two given equation on top. Okay, so we're gonna ignore A. Now let's go to B. When you plug it in, x equals r into this blue one here, 7x plus 6y. Okay, let me rewrite that. I'm going to plug it in x equals r, and y equals to this entire thing. 7r over 6 plus 5 over 6 equals 5. Now for this one, it's kind of funny because when you distribute the 6 cancel, but 7r is not. So you end up getting 7r plus 7r plus 5 equals 5. Very close, but we get 14r equals 0. Then r, the only time that both can equal is when r equals 0. But we want to find the condition that for each real r that will satisfy both conditions, or that will give us the infinitely many solutions. So that's not going to answer this question for each number r. So A is out, B is out. Alright, let's go C. For choice C, okay, so I'm going to start with a 7x plus 6y equals, I think it was 5 actually. Yeah, 5. And let's plug it in, r over 4 plus 5. Okay, so I just realized that r over 4 plus 5, I don't have to go further. And do you know why? When I plug it in, when I just look at the r expressions, okay, I keep forgetting, yeah, this is 5, okay. Now, I don't have to go further because I get 7r over 4, and here I get negative 6r over 4. There's no way these can cancel and give you the number equals number, like what, 120 equals 5. And we also have 35 here. But the important thing is that the r should cancel out here. And they don't. And that's not what we're looking for. So if you're running out of time, then yes, just choose D and move on. But for my teaching purpose, I'm gonna show you how D can work. 7x plus 6y equals 5. Okay, let's plug it in. Oh my gosh, okay. So negative 6r over 7 plus 5 over 7. Okay, I'm not kidding, it's 1:22 a.m. here. My short-term memory is not working well. Negative 6r over 7, 5 plus 5 over 7. And 6 times what's y here? R. Okay, oh thank God. Okay, equals 5. So let's distribute this. We're gonna get 7's cancel, negative 6r, 7's cancel again. When you distribute 7 with a 5 over 7, you're gonna get 5 here, plus 6r equals 5, and look at that, 6r cancel, and we say 5 equals 5. So any r you plug it in will satisfy these top two conditions, or top two equations. Therefore, D is the correct answer.